Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In this video, we're going to talk about temperature rise. This chapter is taken from Chile Mechanical Engineering Design book. Okay, so work done against friction. At steady state, the rate of which work is done against bearing friction equals the rate at which heat is transferred from the bearing housing to the surrounding by convection or radiation. The rate of heat generation in BTU per hour is given by the equation Fs Fb over J, or H generation heat. H is stand for heat. Heat generation is equals to Fs, F force, pi d the diameter, and 60 n is a revolution over 12 J. Okay, uh, uh, and it is equation 5 pi f s f dn over j, which n is the general speed and j is the j equals to 778 feet pound per btu. Btu stand for British thermal unit. Okay, the rate of which uh, where n is general speed in revolution per minute, uh, the rate at which heat is transferred to the surrounding, BTU per H per hour, is given by heat loss. H loss equal to HCR, which is HCR is overall combined coefficient of heat transfer in BTU per hour. A is housing surface area in feet square, and temperature range. Okay, times the temperature range, so you get uh, the A, uh, HCRA. TB is the temperature in the housing, which is in the bushing. This is the bushing. Okay, and TF is the lubricant temperature. Okay, you remember when you pour in the lubricant, what is the temperature of the lubricant that you pour in? This is the TF. Okay, and HCRA over 2, so TF minus T infinity. Okay, so empirical observation that temperature of bushing is about midway between TF and T infinity has been incorporated in equation 1235. Okay, you get TF is temperature of fluid equals to temperature infinity plus this equation 10 by FDN over JHCRA. Although this equation seems to indicate the temperature rise, okay, TF minus T infinity is independent of length L, meaning that whatever length it whatever length, short or long, doesn't matter. It doesn't matter or short or long. Okay, short or long shaft, it doesn't matter. Okay, it will, when temperature rise, it rise. Okay, the housing surface generally is a function of L. The housing surface area can be initially estimated as tuning of the design agrees. Improved result will converge if the bushing is to be housed in a pillow block. The surface area can will converge. Uh, okay, the surface area can be roughly estimated from this equation. Pillow block, you can Google what is the picture of pillow block. Basically, it represent what we have learned from the first video. The theory, every theory for general bearing, the picture that you take, you can see it is related to pillow block. Okay, pillar block, there is a one video on pillar block related to pressure fed bearing. Okay, so the surface area can be roughly estimated from A equals to 2 pi dl over 144. Okay, you put in this equation, so you get T infinity. Okay, temperature of fluid. Okay, roughly equals to T infinity 720 ff and JHCR L. So example 12.8 chooses oils 500 bushing to give a maximum wear of 0.001 inch for 800 hour of use with 300 revolution per minute journal and 50 pound radial load. Use HCR equals to 2.7 BTU, T max equal to 300 Fahrenheit, Fs 0.03, and design factor ND equals to 2. Table 1213 lists available bushing size from manufacturer. Okay. So using equation 1238, ND F for Fs equal to 0.03 from table 12.9 HCl equals to 2.7 BTU. Give this equation for length, you get the length 1.34 inch. And then from table 1213, the smallest available bushing is inner diameter 5/8 inch, outside diameter 7/8 inch, and length is 1.1.5 inch. However, this case for L over D, L distance over diameter. Okay, you divide them and you get the ratio 2.4. Okay, of equation. Then the first trial you get the bushing, uh, or outside diameter 1.18, length 1/2, and then from this equation P max equal to this 113 psi. You see the range exceed or not? This doesn't exceed. Okay, maximum range 3560 is okay. Okay, and then P pressure is 88.9 psi. From equation 1229, velocity is 58.9. Okay, it is below 100 feet per minute. Okay, so doesn't exceed. Okay, then PB equals to uh, 5240 psi. You also check it exceed or not. It does not exceed, so it is also okay, acceptable. So from table 1210, you have to interpolate, meaning that the value you get is within the range. So 33 and 158.9 is within this range. So what value you want to choose? So any value that you think is logic, it is acceptable. F1 equals to 1.5. So for equation 1232, tables 12.8, 12.9, given by W, which is the wear, not the radial velocity. W is wear. Okay. You put in this equation F1, F2, Kn, and this equation you get 0.0048 inch. Okay. So it is also okay. So select inner diameter 3/4, outside diameter 1.18, and length equals to 1/2 inch. So this is the motion related factor, as I have described. What is the rotary? What is oscillatory? What is reciprocating? You see, this is motion related factor already given the pressure characteristic, velocity, and everything. You use it as your guidance. Okay, that's all for the video on general bushing. Finally, the video ends on the general bushing. Uh, I wish you the best. If you don't have the textbook, purchase the textbook because you will use it throughout your career. Okay, so study hard, study smart. I wish you the best. Okay. Assalamualaikum warahmatullahi wabarakatuh.